morning, students. Okay. So today we are going to discuss a case study on comparison of petrol and diesel engines based on the compression ratios. Okay. So in the last lecture series we have discussed about the petrol and diesel engines. So what is the difference between petrol and diesel engine? Anyone tell me? What is the difference? Petrol engine is running by spark ignition. Okay. Diesel is running by fuel injection. Okay. Okay. So what is telling is in diesel engine we are compressing the fuel and then burning takes place. Okay. So what is going to be ignition? Burning. Okay. Can you please come and tell me, by seeing this, can you tell me what is the type of engine, whether it's a petrol engine or diesel engine? How to identify this as petrol engine or diesel engine? Diesel engine. How we are telling diesel engine? Fuel injector. Very good. Okay. It is telling that it is by a fuel injector. Whether if it is a case of an petrol engine, spark. So this is why we have to identify. By seeing this machine, and we have seen the in thermal lab we have seen machine. What is the difference in these two? I have seen this setup anywhere.
Single cylinder.
This is single cylinder. Very good. By as we see the classification, by seeing this you can believe this is a single cylinder. Okay. That is a 4-stroke or 2-stroke. 4-stroke. How we are telling this and 4-stroke? What is there? Valves. Very good. See, in a 4-stroke engine, if you take an engine, this is the total setup where this is the place where the cylinder and piston is set up there. Okay. So here is the cylinder piston and the piston is connected to a connecting rod, and this is then assumed as a crankshaft. Okay. Now this is called as a head. This is called as a head, and this is, you can see here, inside this there is the valve mechanism is controlled, because this is an 4-stroke diesel engine. Here there is valve. The valves should be opened during which stroke? Suction stroke. The valve should be closed in the at the end of the stroke.
Exhaust.
First initially come from first. Then suction stroke, inlet valve opens. When it closes at the end of the suction stroke. Okay. So here, what happens in the exhaust stroke? What happens? Which valve is opening? Exhaust valve is opening, and at the end of the suction exhaust valve. How this valve mechanism is opened? So using a mechanism called as camshaft. So in 4-stroke engines, we need a mechanism to open this valves. So thus we are having this mechanism. Whereas in the 2-stroke there is no valves. So there is no need such this camshaft, this gear trains and all. Okay. So this is the common difference. So now what the engine we are seeing is this is called as a variable compression ratio engine. Okay. What is compression ratio? During
Compression ratio, piston head TDC
Okay. So what is compression ratio is, what is the total volume of the air fuel which is taken inside, and what is the ratio which is compressed. Now we can see here, we are having the compression ratios like this. From 12, 14, 13 like that we are having compression rate. These compression ratios are varying in petrol and diesel engines. Okay. So this is a research setup where in the normal engines this compression ratio is fixed. Here we can vary the compression ratio. The compression ratio can be varied in this engine, and then any type of fuel can be used here. Whether you are making a new fuel with a new blend. Okay. And we can fix the compression ratio, and you can find out the values in this setup. But in the normal diesel engines and petrol engines, only we are using diesel as a fuel in the diesel engine. whereas petrol has the petrol fuel in the petrol engines. But this is a research engine where with variable combustion ratio we can use any type of fuel. Okay, whether it is petrol or diesel, anything we can use, and then we can make a blend and we can find out the properties. Okay. So what is the major properties is the brake power, indicator power, okay, and the friction power. So whatever the power applied in the crankshaft is called as the brake power. And what is the power which is given in the by burning of the fuel is called as indicated power. So at the top of the piston we are having indicated power. At the bottom it is converted into mechanical energy, that is called as brake power. For different types of fuel, by setting the compression ratio, we can find out what is the brake power and what is the indicated power. Okay, so all these values can be fetched from this setup. Okay. So this compression ratio can be varied so that what happens is we can find the efficiency, thermal efficiency. Okay, finally we can find out the mechanical efficiency and thermal efficiency. And also, what is the major issues in two-stroke engines? Now in the market, which is more, whether 4-stroke or 2-stroke? 4-stroke is more. How many? Raise your hands. How many are telling 4-stroke is more? Raise your hands. You please come here. Why? Tell me why we are not using 2-stroke engines.
High pollution.
Yeah, he is saying high pollution. How we are doing that pollution? Can anyone please come? Incomplete burning of fuels. Okay.
Sir, oil is mixed with oil.
For lubrication purpose. Okay. That's coming on incomplete combustion. Okay.
Because of the incomplete burning the carbon deposit atoms. So the
Okay.
pollution.
So some carbon emissions is there. Okay. So there is a more chance of pollution in the two-stroke. That's why we are avoiding two-stroke. So how to measure these values? What are the major emissions in the engines? NOx, carbon monoxide, and particulate particles. These are some of the, and sulfur dioxide. All are the emissions which are coming in the emissions of the burned gases. Okay. By using this exhaust gas analyzer, we can also find out the emissions. Okay. So these emissions can be reduced. So this is the comparison of petrol engines and diesel engines, and where the scope of introducing a new fuel with the varying the combustion ratios. Okay. Thank you.